Okay, counting the number of fringes per metre, which I've noted on the end for my own benefit. So the 100 micron gave 42 fringes per metre at this distance. The 200 micron gave 95 fringes per metre. The 300 micron gave 150 fringes per metre, and the 400 micron slit gave 210 fringes per metre. Now, unless it's an error on my micrometer or something else, it does appear that the number of fringes per metre increases exponentially, only slightly. In other words, you don't get double the fringes when you go from 100 microns to 200 microns. Yeah, that's 200. You get more than double, so 42 doubled, you'd expect that to be 84, but no, we get 95. 200 microns doubled to 400 microns. You expect that to have doubled from 95 to 190, but no, it's gone to 210. And likewise, 300 microns, you'd expect that to be 3 times 100 microns. Well, if 100 microns made 42 per metre, you'd expect that to be 126 per metre for 300, but no, it's more than that, it's 150 per metre. So it does seem to be, there's a regularity to it, it's increasing exponentially, but it's only a slight increase, isn't it really? I mean, they do appear to be roughly proportional, but unless there's an error in my measuring equipment, which is easily possible, it does appear that they rise a little bit more than you'd expect. The number of fringes increases exponentially, but only a little bit. A little bit exponentially, if there's any such thing. I'm no mathematician. And this is just a knit comb, one of the best patterns you can get, really. A 100 micron slit made with a variable slit. 100 microns. A 100 micron slit made with a variable slit. Filmed from about 18 inches away, made with a 100 micron variable slit. 100 micron variable slit. Each division is 10 microns, so 10 times 10, 100. A tenth of a millimetre. The black marks on the top line, they mark the minima of the 100 micron variable single slit. Immediately below that is a pattern from a 100 micron impediment. Lights off. It's immediately noticeable that the impediment is a lot clearer pattern, a lot more distinct. Same fringe width obviously as the single slit, but a lot more distinct. Film from an angle obviously, to try and fit as much in as possible. I've got a camera that doesn't like being in focus. Let's try day vision. Oh. Okay, a 100 micron impediment pattern, equivalent of the previous 100 micron single slit pattern, but much clearer. And there is the 100 micron impediment. Hopefully you can see the 100 micron impediment. Now we have a 200 micron single slit, made with a variable single slit, of course. Okay, so now we have a 200 micron single slit, made with a variable single slit. And it starts to look clearer. It starts to look on a par with the 100 micron impediment pattern. If you're wondering why it's a bit shiny, it's because I'm projecting this onto cellophane, so I can superimpose patterns if I need to later. So it's a single slit, 200 microns, made with a variable single slit. The green markings of the previous one from the impediment aren't really visible, are they? My markings aren't visible in the dark. The black ones are. Okay, a 300 micron single slit. A 300 micron single slit made with a variable single slit. Let's try that in the dark. 300 micron single slit. .300 micron single slit. A 300 micron single slit made with a variable slit. Lovely clear fringes. Okay, so that's the 300 micron single slit duly marked up, and here it is. If you want a little bit of evidence of it. Huh. It's been a bit knocked, okay. That's actually 32. So that's actually 320 microns, but the difference gets less and less with these very narrow fringe widths, but anyway, that's annoying. It drops, I forgot, check it. Oh well, just for reference, I'll correct it. I'll put it bang on 300 and do it again. Okay, hope that's okay. 300 micron, try again. Okay, let's compare. So that's actually 300 microns. Oh, should I mark it? Yeah, come on Steve, stop being lazy. So that's actually 300 microns. The previous one was 320 microns. My apologies. Well, I'm apologising to myself. My fucking birthday, I should be doing something more interesting than this, but happy birthday to me. Happy birthday to me. Happy birthday, Steve brother. Happy birthday to me. 63. The funny thing is, I wasn't 63. I'm still 62. That's how bad I am at maths. Forgot how old I am. I'm 62. Made it, despite coronavirus. Oh, that was in May. You could joke about it then. You can't joke about it now, can you? Yeah, you'll get lynched. 400 microns single slit again. 400 micron single slit. .400 micron single slit with a variable slit. Try that in the dark. 400 micron. Yeah, 400 micron single slit. 400 micron single slit with a 400 micron single slit made with a variable single slit. 400 microns, okay. Now the double slit's marked up in that particular session. Okay, so this is the double slit marked up, the 400 micron impediment with two 100 micron slits. That's the one marked up, and it gives a total of 60 wide fringes per metre, 325 tiny fringes per metre. Approximately a 5-to-1 ratio. I'm not 100% confident about the actual counting, because some of these tiny fringes, they're so difficult to count and mark. I've done my best to mark it as honestly as I can. Now, but interestingly, the central maxima region, I count as best as I can 11 fringes in that region, exactly the same as Gary counted today on a double slit that he'd picked off the internet. I can't remember who he said it was by. Mindless Marbles later informed me it was by Adam Lark, and he gave me the link to it, which was brilliant. The one where he's comparing a double slit directly to a single slit pattern. He was saying that that double slit must have been made with slits which were of the same dimension, the same width as the impediment. But this suggests otherwise, because the ratio here is 4-to-1. 400 micron impediment with two 100 micron slits, and yet we're getting exactly the same ratio of fringes to small fringes to wide envelope fringes. So that suggests that Gary's assumption cannot be right. To be honest, I was quite certain it wasn't anyway, because I'd recently done virtual 1-to-1 ratio double slits with same width double slits to the same double slits with the same width slits as the impediment width, and it becomes incredibly messy and difficult to actually pick out the pattern, because they're clashing with one another, because they're both trying to make essentially the same pattern. And so it kind of doesn't make a nice clear pattern like the one Gary was showing, or the one that this would be if I hadn't marked over it. A classic double slit pattern, that is. I must admit I'm not 100% confident of the declared slit width of these so-called professional slits, because I've checked my micrometers as many times as I reasonably can, and this appears to be pretty bob on, comparing again, coin widths and such like that, checking coin thicknesses and such like. But these lab slides, I'm not 100% confident of the declared width on these. Incidentally, the time I was filming this, May 2020, that was when Gary was telling me that my information was dopey. When I was trying to give him the information about these slit dimensions, the B measurements and the G measurements, and he wasn't interested. But 6 months later he needed that information. He was showing how ignorant he was of what these measurements meant, and he deleted my comment where I'd explained or discussed it with Skyrim, trying to make sure that I was understanding correctly myself, because up until that time I hadn't been understanding correctly, and neither had Gary. But Gary didn't care about understanding correctly. I did. See, that's just how unprofessional Gary is in all his attempts. Isn't the slightest bit interested in accuracy. Is not the slightest bit interested in accuracy. Won't do any due diligence. There you go. So Gary, that's the same one as I sent you a couple of years ago. Which, incidentally, he's completely forgotten he has, because other people have used that same slit and very similar ones, and twice now he's commented saying, talking about this slit as if he's never seen it before. I do wonder whether Gary suffers from a bit of a memory loss or something like that, because he has suffered from Lyme disease, hasn't he? And I have heard recently that can cause similar symptoms to dementia without actually being dementia, so he could have suffered a genuine period of memory loss or something. So it's no fault of his if that's the case, but just putting it out there just in case that explains why he doesn't seem to remember some pretty significant things that he should remember by rights. He probably needs to take notes, Hope it's not one of your birds a hole then. Just to try and calibrate things, this is supposed to be a 75 micron slit on the same slide. So let me mark this up, then do a 75 micron slit with my micrometer, my variable slits, and see if they match up. I don't think they will. I think this one will be over wide. In other words, the fringes will be too thin. According to my micrometer, this is what an actual 75 micron slit should measure. In other words, those lab slides are miles off, aren't they? They're nowhere near the same, are they? So I'm going to have to estimate what the actual lab slide dimensions actually are. Let me measure this. So there's a massive difference between the 75 micron lab slide and the 75 micron variable single slit micrometer slit, which I have more confidence in, to be honest, because I've checked and checked and checked it so many times. But just look at the difference. A 75 micron slit is supposed to be making 24 fringes per metre, but the lab slide one's making 47 fringes per metre. Now this is a 75 micron hair measured with the micrometer. Yeah, so there you go, 75 micron hair. Impediments do seem to produce much better patterns, don't they? Okay. Right, so what it's worth knowing, that 75 micron hair, which should have been the same as all these three 75 micron things should have been the same. The lab slide, my micrometer single slit, and the hair. They should all be given the same fringe width, but they're not. Now the hair is in between the two extremes. The micrometer gives the widest fringe width, the lab slide gives the narrowest, and the hair gives in between. So we've got either 47 fringes per metre if it's the lab slide that's correct, or 25 fringes per metre if the micrometer is correct, and 35 per metre if the hair is correct. Admittedly though, I did measure the hair with the micrometer, and it's a difficult thing to measure, and a very fine human hair, because I do have fair hair. Now this is another 400 micron single slit, but one of those lab slides identical to the one I sent to you a couple of years ago, Gary. The one that's got 3 single slits and a double slit. Talking about this thing, if you can see. Definitely worth buying off Amazon. 3G Scientific. single slit of 75 microns, 150 microns, and this is the 400 micron, and also a double slit with a 400 micron impediment on a 100 micron slits. That one, if you remember, there's 3 on one slide. Well, this is that same one, identical. And it looks pretty shitty, doesn't it, really, compared to the actual single slits, you know, using air rather than transparency, because it's very messy, this, isn't it? Okay, so there's a slight discrepancy between the variable single slit set to 400 microns and the lab slit, which is fixed obviously at 400 microns. There's only a slight difference. My variable slit worked out at 210 fringes per metre, this works out at 230 fringes per metre. Maybe the truth is somewhere halfway between the two. Tiny fringes anyway. Okay. Now this is the double slit on that same lab slide, employing a 400 micron impediment, which should be identical to the 400 micron slit. No, that's an error, my mistake. That was before I'd had this discussion with Skyrame, after looking on the PHILIP HARRIS website and discovering that I was misunderstanding the markings on these slits. Now the G marking on this says 0.4 for what I thought was the impediment marking. On this side, that slit you can see there, that is the double slit, and it says G.4, which I interpreted it as impediment width. It's not, it's the slit centers. This is the crucial information I was trying to give to not only Gary, but all his viewers who might make the same mistake. Now I hammered this out with Skyrame, who confirmed that my suspicions were right, that we'd been misunderstanding. With Skyrame's help, I managed to understand that the G markings means slit centers, and that the B markings means the slit width. And the slit width is 0.1, the slit centers is 0.4, therefore the impediment width is 0.3, because you deduct the slit width from the slit centers to give you the impediment or barrier width, as you'd more properly call it. So this is what I was trying to explain to Gary. That's why I went to the trouble of writing all this information down, a long message that Gary deleted and said was dopey and irrelevant. Then 6 months later he needed that information when he was misinterpreting similar slits, getting it all wrong. Even when I sent him these slits though, he misinterpreted them and he had them in his hand. He's wrong to keep deleting messages when they're full of important information. It's wrong of him to delete information, really, I think, that was intended not only for him but everybody else who might need this information too. So we can all learn to interpret this information properly. It must be made in Italy or something, I don't know. Why would you call the slit centers G, and why would you call the slit width B? I don't know. G and B, there's nothing logical about that, is it? It's as logical as B and H, the magnetic plane and electromagnetic radiation. I'm going off at a tangent now though. At least I'm willing to admit my mistake. I'm willing to seek help from people like Skyrame and Mindless Marbles, who are fantastic people to help us knobheads who make these mistakes. They tend not to make these mistakes, it's us who make these mistakes, but Gary can't accept that he makes mistakes. He does. Oh boy, does he. And 100 micron slits, which should be equivalent to the 100 micron slits I've already marked earlier. So that's 400 micron impediment. No, Steve, 300 micron. And 2 100 micron slits, a total of 600. No, that would be a total of 500. 300 impediment plus 100 slits. That's got nothing to do with the price of fish, has it? Catch from my distance. The small fringes of a double slit pattern are always very tricky to film. I suppose it depends on the quality of the slide you're using. I thought these were professional. Well, they're reasonably professional, but yeah, they aren't fantastic, are they? Okay, that's what I'll do for now. I'll mark this one up and measure. Okay, this is one of the Unilab unmarked double slits. Incidentally, this is just about the time, this is just at the moment when I was getting fed up of not knowing the actual slit widths of these Unilab slits. So I had one more go at Googling it and stumbled on PHILIP HARRIS's website, where they gave the actual full details of the slit widths and the slit centers and so on and so forth of all 9 of these slits in this particular range, because these come in a set of 9. 1, 2, 3, 4, 5, 6 slits, then 3 different gratings.
and I always had to guess because they aren't marked on. So I was so grateful to stumble on Philip Harris's website where they gave the actual dimensions. So I had to write them on the back for posterity. So let me just read them out. So all 9 of these slits in this Unilab series of slits are, the slits are 62.5 microns. That's a bit accurate, isn't it? 62.5. Right. And 250 slit centers, 250 micron slit centers. So if it's 250 slit centers, then you deduct 62.5. That gives you 187.5 impediment width. Is that right? Have I done that right? Have I done that right? My math is rubbish. 187.5 impediment barrier. Is that right? Anyway, at least we know now.
I've already marked it though there. This is the markings of this, the one that's live now, the one you can see. This brand of slit, which looks like this in semi-darkness. Now the 6th slit, I've jumped straight to the 6th slit. I've not done the 3 or 4 or 5. Straight to the 6th slit of this same brand, which is a very complex pattern. If you look close up at it, I don't know if the camera can pick it up. There are all sorts of tiny fringes within fringes. Try again. It's a very elaborate pattern. I'm running out of camera time. I don't know if I can really mark this with any. I can do the central maximum but nothing else perhaps. So there you go, 6 slit but they're same brand. Now the coarse grating version of the Unilab slides. Same brand, but the coarse grating. I think it's probably the same pitch.
Well, I was half right. Now let me give you the information because there are 3 coarse gratings in this set, and I really do recommend you buy these off Philip Harris's website or try and buy them second hand. I got them for about 10 quid, but they cost about £90 for the full set. But it's worth it though because they're fantastic slits. These are really good. So there are 3 in this series, coarse grating 1, 2 and 3, but they don't give you any more information than that, but Philip Harris's website do. So let me just tell you, if you happen to have these, then you've got this information. Coarse grating 1, as you might imagine, is simply the same as a 2 slit or a 6 slit, just multiplied by 100 or so a grating with those same slit dimensions and same slit centers. Okay, so that's the same as a 2 slit effectively. So a light through that just gives you the same double slit pattern as a 2 slit, but more like very accurate dots with massive gaps between. Okay. Now the next one, coarse grating number 2, is the same again but half width slits, and coarse grating number 3 is half width slits and half separation. So that really just ends up being, the same as this one, but with twice the width fringes, because you've halved the width of everything else. It's more complicated to explain than observe.
Same fringe width, I'm guessing. I've marked it, but I've not checked yet in the light. So that was that, coarse grating number 1, that was the Unilab slide, and I have 2 more of these I've not used yet. Yeah, so that's the bottom one, and it does appear, doesn't it, to be making pretty much the same pattern, same fringe width. Okay, here are the results then. So we've got the unmarked slit, the 6 slit and the grating. There are the measurements at the end. 6 slits makes 40 wide and 160 cm per metre, and the grating is just slightly under that, 38 wide ones and 140 thin ones per metre. And there they are.
I didn't quite finish marking the central maxima on the middle one there, did I? They should all be identical anyway, shouldn't they, more or less?